I'm here with Jean Lapierre from Matrox, and they've got a really cool Vero generator, and I wanted to talk to Jean about some of the details on it. So, Jean, just tell me what stimulated its development.
Well, Matrox Vero got the idea behind Matrox Vero. It got born by our implication in what's called the JTNM tested program. So at the beginning, manufacturer would go to interrupts and the events, and they would test that their gear works with other manufacturers' gear. And then we would end up doing demos at trade show to show people that, yeah, ST2110, it's working. See, this gear can talk to this gear. But manufacturers were disappointed because once they got the gear into their facility, it doesn't always interoperate as it was promised in those demos. And so the tested program got created to test equipment and to validate that it actually supported the specification, so that this equipment would then guarantee to be interoperable with other equipment, right? So if it works according to the spec, then it should work when you connect it to other equipment. And so in doing those kinds of tests, we realized pretty early on that it's easy to test a sender. You send the signal, you capture the signal, you analyze it, and you say, yeah, it adheres to the spec. The tricky part is when you try to test the receiver, because all you can do is send it a signal and say, yeah, that worked. And so the idea behind Matrox Vero is to become that piece of equipment that can generate a signal that can be perfect signal, but a signal that can also be a less than perfect signal, like a wide signal and anything in between type things. So that's how Vero got born, behind the idea of being able to test equipment for the tested program.
Right. So, and that's certainly the whole wide narrow thing. You got to test those aspects to make sure they're working well. On the other hand, though, if people just want to have a simple source to get going, why not just take an SDI to ST2110 converter and move on?
Well, that's a good question, because like if you use a converter, an SDI converter, you're going to end up with a signal that's pretty much a narrow signal, a very good, I wouldn't say perfect, but a very nice, stable signal. And one of the flaws we discovered during the testing program is that we would take a piece of equipment that we pretty much knew was a good sender. We tested it at the beginning of the event to make sure it was passing all the tests. And then we use that as our reference during the whole event. So what you end up doing is verifying that your receiver can basically receive a perfect signal. And for broadcasters, what they really want is equipment to be robust, right? So they want to make sure it works with a nice signal, but also with a less than perfect signal, like a wide signal. And so with Vero, the idea is that you're able to generate signals that are cover the whole spectrum. Perfect, less than perfect, even beyond less than perfect. I mean, we had some users telling us that they want to be able to bring the signal to the edge of compliance and then push it beyond to see how the receiving device behaves. And for them, it's important because they don't want it to crash when things go a little off center type thing. And so using a converter doesn't give you that. We had a customer actually that used a converter and connected it to a network emulator that could modify the signal to generate these out of spec signals. And it was described to me by that customer as a duct tape solution, a very expensive duct tape. And it didn't even come close to what you can do with Vero.
Yeah, it sounds pretty complex, and getting too many little bits of kit in the loop doesn't help as well with regards to reliability and trying to figure it out. Now, you also included a capture capability in this.
Yeah, we did, because since that's because of our involvement with the JTNM tested program. Um, since it's pretty easy, like I explained, to test a sender. I mean, you make it send a signal, you capture that signal, and then you analyze it with software like List that can generate then a report that says your device follows the spec or has this problem or that problem. The thing is, when you're trying to capture this file that List uses, it's called a PCAP file. So a PCAP file is used by network traffic application to store packets grabbed from a network. And in order for List to make a good and accurate analysis, it needs a PCAP file that has no drop packets in it and that has very accurate timestamping information. And you can build a system to do this, but it's fairly tricky, because capturing a 1080p uncompressed signal, that can be a challenge, but capturing a UHD signal without dropping any packets, that's nearly impossible. So anyway, the EBU tried to document how to build this system using an off-the-shelf computer and a network card that supports PTP and everything, but it gets pretty tricky to configure, and then people were still having problem getting it to work reliably. So that's why we decided to include that capability in VERO, to capture ST2110 PCAP files that have no drop packets, that are accurate, so that the List software can be used to analyze the signal. Actually, we also decided to include the List software in the VERO for convenience. So you end up having everything you need for testing your senders and your receiver in one place. It's convenience.
Yeah. Well, one thing I was really impressed with on your website, you've got some videos up of how simple it can use it, and it was like really cool. Drop down boxes and a couple of menus and whatever, and you can just nip in, and even if you need to change the IP address, it's super simple.
Yes, it is. I mean, you have to realize that we didn't build VERO only for this certification program, like for manufacturers that really know all the details of ST2110 for the manufacturer. We also built it for broadcasters and system integrators, so they would have a device that they could use to test, ST2110 devices, either that it's compliance, like the manufacturer, or maybe before deploying them on a network for the system integrator. So for us, it was important that it was easy to use and easy to set up. I mean, one of the big comments we got from our couple of first beta testers, like, well, this thing is really easy to set up. I plugged it on the network and I went to the web page, and it was there, and I started using it within minutes. I didn't have to pour through like thick manuals, and it was pretty much play with the interface and you figure it out type thing.
Oh, I was impressed with how simple it is, and you don't have to be a 2110 expert to be dealing with it, which again I think makes a big difference. The other thing I noticed is you added in both fill and key.
Yes, I guess Matrox is a manufacturer also of OEM equipment, and some of our customers are big CG companies type thing. So for us, fill and key has been in our DNA for years. And so when we approach ST2110, for us, in standard SDI, you basically have two signal, one for the fill, one for the key, and they're actually full SDI signal, even though a key is only the luminance value. In ST2110, the spec includes a specific format for sending just the key, right? So it's instead of having to send a full video for the key, you can actually send just a key signal now over ST2110, and that's a little different than a regular video would be. And so for us, because of our customer base, that was very important to support that with our gear, and VERO is no exception. So it's
Yeah,
in VERO as well.
I think that's super impressive that you've added in the key aspect to that. It's very unique. I haven't seen anyone else do that at this point anyway. Anyway, thanks for the chat, Jean, and really impressive product.
Thank you. Thank you for having us.